Hello all. Let us now discuss about Coulomb's law and principle of superposition. Coulomb's law, it is one of the cornerstones of electrostatistics, which quantitatively explains the force between electric charges at rest. Before Coulomb, scientists know that charged objects could attract or repel each other, but the exact relationship governing this force was not known. So in the year 1785, the French physicist Coulomb performs a series of experiments using torsion balance, and he has established the mathematical law that now bears his name, Coulomb. So this Coulomb's law describes the electrostatic force between two point charges placed at rest in a given medium. According to the law, the magnitude of the force between two stationary point charges depends on three important factors. The first factor is the magnitude of the charge themselves. The force between two charges is directly proportional to the product of the magnitude of the charges. This means that if the product of the magnitude of the charges, this means that if one charge is doubled, the force becomes twice as large. If both charges are doubled, the force becomes four times larger. The second factor is the distance between the charges. Coulomb found that force is inversely proportional to the square of the distance between the charges. This inverse square relationship is very important. It tells us that if the distance between the charges is doubled, the force becomes one-fourth of its original value. If the distance is tripled, the force becomes one-ninth. The third factor is the medium between these charges. The electrostatic force is strongest when the charges are placed in vacuum or air. When the medium is changed to materials like water, glass, or plastic, the force actually decreases. So, this reduction occurs because the medium partially shields the electric interaction between the charges. So, Coulomb's law also explains the nature or direction of the force. When two charges of the same sign, both positive or both negative, are placed near each other, they experience a repulsive force and move away from each other. When two charges of opposite signs, one positive and one negative, are placed near each other, they experience an attractive force and move towards each other. So it is given by F12 vector is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 square R12 vector. So here the force F12 vector will be opposite to F21 vector. So here epsilon naught is 8.86 into 10 to the power of minus 12 c square divided by n m square, or it is 8.86 into 10 to the power of minus 12 F meter inverse. So the F12 is the force exerted by Q1 on Q2, and F21 is the force exerted by Q2 on Q1. And another important characteristics of Coulomb's force is that it is a central force. This means that the force acts along a straight line joining the center of the two charges. So there are no sideways components. The interaction is purely along the line connecting the charges. So this Coulomb's law is a vector law, meaning that the force has both magnitude and direction. The direction depends on whether the charges attract or repel each other. So the limitations of Coulomb's law are: this law is valid only for point charges or for charged bodies whose dimensions are very small compared to the distance between them. It applies only to electrostatic conditions, that is, charges must be stationary. Also, the law is strictly accurate in vacuum or uniform isotropic media. Despite these limitations, Coulomb's law is extremely important because it forms the foundation of electrostatistics. Using this law, we can define the electric field, calculate electric potential, analyze capacitors, and understand the behaviors of charges in electric circuits and electronic devices. So Coulomb's law also shows us close similarity to Newton's law of gravitation, as both forces as both follows the inverse square law. However, unlike the gravitational force, the electrostatic force can be attractive or repulsive and is much stronger in magnitude. So, Coulomb's law provides a precise and experimentally verified relationship describing how electric charges interact. It tells us how the force depends on charge, distance, and medium, and it serves as a starting point for almost every concept in electrostatistics. Now, let us discuss an important principle used in electrostatistics known as principle of superposition. So, this principle helps us analyze the effect of multiple electric charges acting together. In real physical situation, we rarely deal with one or two charges. Usually, there are many charges present and each charge contributes to the overall force or electric field. The principle of superposition provides a simple and powerful way to calculate the combined effect of all these charges. The principle of superposition states that when several charges are present, the total effect at any point is the algebraic or vector sum of the effects produced by each charge acting independently. This means that each charge produces its own electric force or electric field as if no other charges were present. These individual effects do not interfere with one another. The final result is obtained by adding all these individual contributions as it is shown in the formula Fr vector equal to 1 divided by 4 pi epsilon q1 divided by r12 square r12 vector plus q2 divided by r13 square r13 vector. So to understand this more clearly, let us consider a case of electrostatic force. Suppose a charge is placed near several other charges. Each surrounding charge exerts its own force on the given charge. According to the principle of superposition, the net force on the charge is obtained by adding all the forces due to the other charges, taking both magnitude and direction into the account. Since force is a vector quantity, this addition must be done using vector addition. Some forces may act in the same direction and reinforce each other, while others may be opposite direction and partially or completely cancel each other. So the principle of superposition also applies to the electric field. Each charge creates its own electric field in the space around it. When multiple charges are present, the net electric field at any point is obtained by adding the electric fields produced by each charges individually. The important point to note is that electric field at a point depends only on source charges and not on the presence of a test charge. So this makes superposition particularly useful in electric field calculations. So similarly, superposition is valid for electric potential. Since electric potential is a scalar quantity, the total potential at a point due to multiple charges is simply the algebraic sum of the potentials due to the individual charges. No vector addition is required in this case. So here the electrostatic interactions obey linearity. This means that response produced by multiple causes acting together is equal to the sum of the responses produced at each cause acting separately. So both of this linear behavior, electric forces, fields and potentials can be superposed. It is also important to understand the limitations of superposition. So this principle is valid only when the charges do not alter each other's positions or magnitudes. If the charges are free to move, their redistribution may change the force or field configuration. Superposition is almost accurate in electrostatic conditions where charges are stationary. In highly nonlinear media or under extremely strong electric fields, small deviations may occur. Despite these limitations, the principle of superposition is extremely powerful and widely used. It allows us to analyze complex charge configurations such as electric dipoles, charge distribution, parallel plate capacitor, and electrostatic shielding. Thank you.